And I will also record. And we are live. That worked beautifully. Okay, hey, everyone, it's session number 51 of Amplifying F Sharp. That means we had our big anniversary session 2 weeks ago with the great Scott Flashin. And if you missed it, go and rewatch the video because it was a really nice take on his history with computing and programming languages. And it's always nice to hear some war stories, how it was back in the days compared to today, what's better today, what was better back in the days. And yeah, I really enjoyed, and a lot of other people enjoyed as well. So yeah, give it a spin. You won't regret the time spent there. And as always, a little housekeeping. If you also want to do a session with us, here's our join us form. It's pretty straightforward. You have heard it before, or just get in contact with one of us if you're interested. If you are in the position to spend a little bit of money for the F# ecosystem to keep it healthy, our collective is still ongoing, and we would be happy to have some money for some bigger initiatives there. And also there's still the great idea or the great goal of turning Edgar's hair into blue, because that's just a life goal of us, of course. That's basically why we are doing all of this. And last but not least, the F# Essentials lectures had their final session, I think also 2 weeks ago. And yeah, they're all recorded, and the people participating in it were quite happy. If you missed it, we watched them. There's a lot of good groundwork, good basics, but also a little bit more for the advanced people. So yeah, good content. And thanks again to the people involved, to Ian, to Edgar. It was really really nice to have all these weeks of content on a steady basis. So speaking of content, today we have a special guest. It's Vlad, the head of the F# compiler team, and his topic will be FTRAP, the tree sitter implementation for F#, or the grammar for F#. It's an ongoing initiative. A lot of people are interested in it. A lot of people have a little bit of issues really understanding what it's all about. And Vlad is here to hopefully help us and the other people getting going with tree sitter. So I don't bore you anymore and give it up to Vlad.
Cool. So hey everyone, I'm Vlad. As you know, thanks Dave for the introduction. I'm just gonna jump straight into the sharing my screen and just kind of trying to explain what the tree sitter is, and why people use it, and why is it kind of an interesting technology. And if someone has any questions, or like if we have time, we just go dive through maybe some of the how things are implemented, and maybe fixing like some small issue if we find. Let me share my screen. Do tell me if the font is too small, too big. So I hope you can see it. And from kind of I'm going to start from beginning, like what the tree sitter is. Tree sitter is the parser generator tool and parsing library, incremental parsing library. It can build like specific syntax trees for a source file and update it, and then incrementally update it if only part of the tree has been changed. It's supported by I think it's fully supported by Z, Emacs, and NeoVim, might be Vim, I'm not sure. And I'm pretty sure there are like some third-party libraries for other editors. And from what I know, um, many editors are exploring the support of the loading custom three-seaters grammars. The good thing about it is can be compiled to virtually anything. You can get a WASM library. You can have dynamic library out of it. I think you can get the JSON representation of the grammar out of it, use it, whatever, like in your web tooling, in your IDE, in your, pull or merge request UI. It's just up to you. So TreeSeeder for F# is a community project. It recently moved to Ionite. I'm pretty sure someone will drop the link in the comments or in the description if you're watching it in the recording. And it sort of has two main parts, which is grammar itself, grammar.js. Your typical JavaScript files based off of the latest 4.1 official spec, as well as some changes, for example, for static constraints for in this RTP inline functions. It's just a description, of the grammar, which you can find in your typical grammar software. For example, here we see how the named module is getting described, module, and then it dives down into additional stuff which is described in the same file. And then there is a file called scanner, which is a additional logic, which in case of F# accounts for white space sensitivity, indentation and indentation rules, and things like comments. I think they are special for the scanner. So that's the structure. You will find it on a GitHub under the Ionite. It's very easy to start with it. You just need an npm and a C compiler. I think it uses GCC or default CC, which is configured for your system. And then you just do npm. So sorry, it's the examples. We go to the TreeSeeder. You just run npm install. It will. I have everything installed, but it will install all the dependencies and everything it needed. And then npm run build, which should hopefully. Oh, nice. It builds the binary of the TreeSeeder. You can continue. You can explore. Actually, you can explore everything it can do by just running npm run. So this command is custom. I added it for the sake of this demo or this presentation. But like others, as you progress or as you change the TreeSeeder grammar, you may find all of those really helpful, especially parse and debug. As an example, so once you build it, you can straight start playing with it. So you can do npm run parse and pass it any F# file you want. So I have the TreeSeeder F# example, and then I think it's program fs. Perhaps examples. Yeah, here we go. So it's going to parse the file and it's going to output the tree. Trees in a TreeSeeder are present by the S expressions, and the query language, which I will explain a bit later, also is a pretty much scheme or some sort of Lisp, some sort of S expressions. TreeSeeder is mainly used for highlighting stuff and querying stuff. So, and both highlighting and querying are, implemented in the Lisp-like language or S expression like language. Highlighting is obvious, I hope. Like you declare a bunch of variables, or like you write a bunch of queries which you can extract, for example, the value declarations or function definitions, and then assign them to all of them into some sort of assign them a variable. And then for that variable, you can say, oh, it's going to be red or it's going to be blue. And then, like the tree sitter will do the rest for you, or like tree sitter engine, which is running in your IDE, will do the rest for you. So you are responsible only for the classification. And the classification is usually well known per editor. Second thing is querying, and querying is kind of the same, but more interactive. For example, if you want to implement highlighting in your editor of something under the cursor, you can, you can highlight it, then pass it to the tree sitter, and then find all the occurrences with the same name and highlight them. I will try to demonstrate it later. The specific F# tree sitter implementation also has a bunch of tests. It's not by any means covering like the 100% of language. I even doubt it's covering 50% of language. This is the great place to start contributing. Even if those tests will contain errors, they are very helpful, because as people will try to change the grammar itself, they will see that something is breaking or like something is fixed. One example of the test I can show you here is, for example, we want to see how type definitions are parsed. So you see that the tests are just text files. From what I know, it's how it's usually presented in a tree sitter tooling, or like in tree sitter implementations. So we have a test, source code, and then the tree which we expect. So we have a bunch of them. You can just add a new one and to the run the npm test. Yeah, and it's going to just run everything. As you can see, it's quite fast. So what else? You can debug how the parsing is working by either running the npm run debug, and let's see if I can just debug and then path to the file, and you will see very verbose output of how it was going from character to character, and looking ahead and then trying to reduce some stuff, and the assigning things to the ranges, and in the end, what was the tree, the parse tree it resulted in. Very helpful if you stuck in some expression is not getting parsed correctly or as you expect, and you need to just debug it. You can narrow down as much as you want, and it's gonna parse this atomic specific thing. Let's see. I will talk a bit more about queries. I want to talk about a bit more about queries. For that, I'm gonna probably just open some example. Let's see. So just your normal F# program, we declare we do a binding, which is a function, and then we call it twice. And let me see. So there is an extension in the VS Code directory, which is called Astronomer. What it allows you to do is that allows you to load a custom language, like WASM module of the custom language, tree sitter WASM module of the custom language, and then see the tree as you go and run queries against it. I think NVim also has, which is called Tree Sitter Playground, and Emacs has something similar, but I haven't used it. So, oops. Let me reopen the file. So your typical program can actually just, I have prepared queries, but we can just try and figure something out ourselves. So for that, I want to go back to the repo and say npm run build wasm. So this is the custom command. Alternatively, you can do tree-sitter build -- wasm, I think. Yeah. So what it's going to do is going to download the Docker container for like which will have like every dependency to compile your thing to WASM, and going to pull the file to your local machine. You can see here that it it's your typical WASM file. So let's see, we can try and load thing here. So in VS Code, the identifier of F# is just F#, and do not be mistaken with the C#, which is with underscore. It took me a while actually to figure out why it's not working. So let's see. Let's load our tree-sitter WASM module. I don't think it's going to say that it's loaded correctly, but yeah. So if we reload the tree, you on the right hand side, you see the sorry. If we reload the tree for the specific open file, we will see that it loaded up the tree for it, and you can just go through the declarations and applications and whatnot. So let's see if we can. So the simple queries for the tree-sitter are just as expressions. So we can try do something like we want to do all function or value definition before I execute it. So just to explain this, this name, this name function or value definition comes from grammar, from the JavaScript grammar in the tree-sitter repo. So if you try to find it here, you're going to find its definition here, which is literally says like, oh, it's going to start with a let or let bank. It's going to have a either body or a recursive keyword and the body. And if you go to the body, oh, it cannot navigate. Doesn't matter. So like if you will navigate to the body, you will see that the body definition will be something else. So it actually doesn't matter right now. So like if we go back to our query, we can just execute it and see it just highlighted the whole range of the function, like function definition. You can inspect it in the tree itself. You can just click it. It's actually a bad example. You can click it and it will highlight the whatever is under your cursor. Also, it's sometimes helpful to toggle the line numbers, and it's gonna just show you the what's up. But just function or value definitions is kind of useless. So let's try and extract the identifier of this thing. So what we can do is that we can have another expression, which is a function of value definition. In this function of value definition, we have function declaration left. So we want to do that or select it left, and then inside we have identifier. The usual thing with Lisps, just count your parentheses. And so it did select the whole thing because we just kind of told it to, because we just say that the topmost left thing, it's like which is going to be kind of selected. But if you just want to extract the identifier, you need to kind of bind it. for the lack of the better word. And for this, I will need to go into my cheat sheet because I'm not super proficient yet with tree-seater queries. So the binding works. You just you just write a selector, and then after the thing you want to bind, you give it a name, starts with a @. So, and first it's gonna select the full expression, and then like when you gonna do the next, it's gonna filter out the say hello name. Sorry, the name or identifier of this thing. The tree-seater supports queries, which is helpful in the kind of scenarios when you need to do things more interactively using the tree-seater, like highlights or like get ranges of all things which are mutable or recursive. So as an example, again, it's a very artificial example, but bear with me. So we wanna. So here we're saying we wanna get every identifiers, every single identifier in the source code, and then we wanna give it a name, like bind its name to the FN ident name, and then apply a function EQ, which is just an equality, and say, oh, I want to iterate over every identifier which name is say hello. Let's try running it. So we have the declaration. We have the first occurrence, and we have second occurrence. It selects it twice, but I think it's a bug of this thing. I couldn't figure out yet because when I was running the same query in an NVim, it was just showing me this once. But maybe it's capturing identifier. It navigates you to that, and then it navigates again. It's if somebody can figure this out, let me know because I'm it's kind of annoying, but I can deal with it. What else? We can so sometimes when you parsing something or like adding a support for certain language construct, or like you do the you want to fix something, there can be errors. And as an example, we can just go we can just go to the F# repo, to the source compiler, and get some. Let's see. Optimize sounds like a good one. We open Optimizer. We reload the tree. We see it's a lovely 4,000 lines file, not the biggest one in the repo, but you can see it was parsed, like it parsed all of them quite quick. But you see the error here. It means that somewhere in the tree there is an error. So we see that like the first line starts with a line comment, and it parsed correctly, some impers declaration, and access modifier for the module. The problem is sometimes it's hard to find the error, and you don't want to scroll through the hundreds possibly of definitions. The easiest thing you can do is you can just use the query. You wanna go through errors, and the first one would be it's the hash bank, or sorry, hash directive, which is surprising actually to me that it doesn't support it. We can actually go and try and fix it, I think. Let's see. We open the grammar, and so yeah, so we can parse the basic. So like we want to do the basic stuff. We don't want to parse whatever like the different directives into different blocks. But like for now, we as an example, we can parse it into the something which we'll call basic hash directive. Oops. Which will be extras, and it will go to the scanner, like as in a, the scanner, like the custom scanner, and it will be handled there, or like, it will expect the that it's a special block, like a comments or block comments or XML docs. And by doing this, we will also be able to, in the like we will be able to support custom directives if they add it to the F# lexer and parser without changing the, like this grammar. So it's like it's just going to be a special thing. So next, we probably want to do, hold on. We want to probably find where the something like line comment is handled and add it there as well. So we want to have an external basic hash directive, and we want to do, oh yeah, and here is the actual kind of declaration. It's kind of for the like constant things which are in the source code and rarely in the resulting binary. Basic directive, and then we do a no, we do, what do we want to do? We want to do the lambda, which returns a regular expression, and we say we want it to be starting with a hash, and then anything except line ending, like any of those. It can be, it cannot be like a line ending. Probably something like this would work as well. And then something like but I'm not too keen about debugging regular expressions today, so let's just do this thing. Yeah, so hopefully it's right. And the last thing which we want to do is we want to go to source and the scanner, and here among the special like tokens, we want to do the basic hash directive. I hope I didn't mistype anything here because it would be embarrassing. I think that's it. That's it. That's all we should want to do. We can go back to terminal here. So we have only a few things changed. So we're going to clean the repo, and then we want to do the I think like it will just populate node modules, which may take a while. I shouldn't have done this, honestly. But yeah, like I wonder if anyone has any questions. It would be a good time to answer them.
The grammar, that we're using for tree-setter, it is directly related to the parse FSY that we have in the F# compiler, right? So it is a way to see the mapping one-to-one. Is that right?
Well, not kind of, not really, but ideally we probably want it nearly one-to-one, but it's just too different, like to the FSLexYAC. I think we wanted to have it kind of separately, and I'm not sure if we can. What would be the best way of ensuring that it's up to date? I don't think that this was based on the parse FSY, but rather the specification. If you, as you may know, specification had the the very basic definitions of the what is the syntax, and I think it was based on that.
Okay. Yeah.
So this thing npm install is done. So now we do npm run build. It's going to take a bit, and then build wasm or tree-setter build --wasm. Oh yeah, it's gonna take a bit. Let's see. Yeah. We switch back to optimizer. We can go and register it again. So one thing unfortunately I think it doesn't support reloading. Oops, 3C3 F# was, and we reload the tree. Still an error, but let's see if it's the same error. So if def, oh no, it's not if def, it's if. So let's see. Actually, let's just query. That's the first one, and yeah, so now it's something else. As you can see, it's the double et, which is an operator. But now the debug is working. So like, we can just go. Hopefully it's gonna work, and we're gonna basic hash directive. And yeah, here we go. Like this is kind of was a quick dirty fix. I would if done properly, we should have the basic directive, which would include the directives like hash line, which is not paired, and the directives like if, else, and if, which are paired like if it was condition. I wonder if it's like yeah, so like we have the expressions here. It would be the same kind of, so like implemented in the same way, but like instead of if then it will be hash if, and then hash if else, and then hash if and if, or something like that. So this is sorry, it was maybe a bit random explanation of the three-seater, but to kind of recap, the three-seater is a parser generator. It can generate parsers for your language, can be easily compiled to pretty much anything you want, can be loaded and used like using the same interface. It's described on a three-seater website. I think it's at threeseater.org. No, it's let me share it in the chat. It's here, and it can be really helpful for really fast coloring of your source code, because it's kind of fast, and like most of the implementations I've seen, they are like they can like go through thousands and thousands of lines like it's nothing, and the rest is up to editor how to color them. Second application is obviously the querying and running your stuff, like your custom commands based on those queries. Like like you wanna go through all the mutable variables in the current scope. You can do that. Like you can determine current scope using the the ranges, and like do the next function, or like binding from the current scope, and then you can in this current scope see everything mutable and do something with it, or suggest user to do something. It's obviously not as good and powerful as semantic analysis or things like analyzers, because analyzers have much more stuff, or like much more knowledge about project. But this is definitely something we would like to have, and basically for reasons like, hey, we want to good F# support in Z, we want a good F# support in NeoBeam, and together with a FS autocomplete, I think it's it would be good addition to the tooling. One more reason to have something like that. I'm sorry, I keep interrupting someone.
There's a question from Robert on YouTube, just for confirmation. I think is the intent of three-seater to eventually replace the F# compiler's parser, or just to support tooling? I guess it's just tooling, right?
It's just tooling, because well, multiple reasons. First one is that there are inevitably some quirks in the FSLX YAC and how the parsers work there, and it would be very hard work to to ensure that like they behave the same. Because like we care about backwards compatibility, and like we want to make sure that like you have your code, you update your SDK, and it's parsed the same way, and it selects the same way, and we compile it the same way. Regressions happen, but like it's much easier to manage in the like FSLX YAC, the existing one. Probably the other reason is we have expertise in FSLX YAC, and we don't yet have it in a tree-seater. Ideally, like in the ideal world, we would generate one from another. Like the one to take one as a source of truth and generate for example, the grammar.js and the scanner from the parse FSY, for example, or Lex FSL, or both. But I tried to explore it a couple of years ago, and it turned out to be like I kind of time boxed it for myself, and it turned out to be a much harder job than I anticipated. I'm not sure how we are in time,
Sorry.
but yeah, sorry, go on.
For interrupting. I have a question. So right now, like we don't have like a very good support of F# in UVM and NZ. Is that because like for F#, you need to go and implement a custom plugin in UVM and another plugin in Z, but this way we will have like one implementation, and it just like plug and play in these two editors.
So the tree-seater is mostly about the kind of syntactic structure of the like support of the syntactic things in the editor, in the NeoVim, including like I know it has the highlighter plugin or the scoping plugin. I'm not sure how it's called, like this virtual line on the top, like sticky line on the top of your editor. Many languages use the tree-seater for that because it's super fast, and the tree-seater is able to you can see the scopes, or like it can parse files so fast so you can almost immediately show the users the scopes. Another thing is LSP, and there are two sides to that. So like LSP is, in my experience, is very good with the FS autocomplete, but I don't have experience in using multi-language solutions, which are like mixed C#, F#, maybe VBNet solutions, and I don't have experience in that. However, we do work on moving to LSP in Visual Studio, which will inevitably, like we already work with the Roslyn team for them to kind of open up more multi-language project capabilities, like communicating between two LSPs. For example, FS Autocomplete, Ionide, and the Roslyn LSP, or whatever it's called now. So not entirely sure answer to your question, but the tree-seater will improve syntactic part of the like editors for sure, and like the other, like autocomplete and the diagnostics and the semantic highlighting, it's up to LSP. And again, like if you have any issues, let's like report them to the compiler repo or to the FS autocomplete repo, and we just couldn't go from there and try to fix it. Alrighty. Oh, I don't think I can show you much more without like really diving into solving some issue, which may take hours. Yeah, just go ahead and if you're interested in contributing or just exploring, go ahead and look at the TreeSitter GitHub website. It has a playground for kind of more popular languages, or like the languages which have mature TreeSitter parsers, including JavaScript, Java, C#, Go, TypeScript, even YAML, and you can play there with trees and queries and see see how it works for you. And yeah, like if you have any if you want to contribute, I would say the easiest way of contributing, or the helpful and easy way of contributing, would be to contribute to tests. Because if you will start adding tests, it will start showing where the errors are, and it will be easier for people to see what they can pick up and what they can try to fix, like in a kind of smaller bits and pieces.
Question, Vlad. So basically, the way that you show us the error that you found into the optimizer FS was by using this plugin, but this plugin, right? So another way will be, as you mentioned, like write the unit test, run and see where that fails, and then kind of do the same process that you did, update the grammar.js, then the scanner, and then follow that same.
Yes. So if we have a couple more minutes, I can quickly show. So we can go to the operators, and we can see, we can so we can just duplicate this test and say, we want to test add operator, and we want to say that what was it? Add. Oh, let's see. Can just paste the piece of code which is problematic, sort of, and which you can find either navigate to it here in the list just by clicking like any error, and I close the file, and that's why it's not navigating. And then you can say here that you expect the error, and then you to the npm run test, see if it fails. Yeah, so oh yeah, so see, now a bunch of tests are failing because we added a basic hash directive, and now it's parsed as being on top of the file. So we might want to update those. And I think that at least it should have, it should have the way of how to update those test files, hopefully. I don't recall that, unfortunately. I haven't looked at the README for a long time. So yeah, like we have this test, for example. This is the baseline. I will just, for the sake of time, for the sake of not getting too much of the extra time, I just go and paste it here, and we have this baseline. We can so once we run test again, it's gonna just not fail, because we say like, oh, this is what we expect, and errors are part of the expected baseline. And then you can start. My approach is usually I can just go here, create new file. Whoops. Create a new file, just paste it here, reload the tree. Will it reload? Oh, it needs to be saved. So if I will go and save it as a test fs, yeah, so it's gonna parse into the error, and I can see that I can find the error, And yeah, so it's like add.
I see.
Unfortunately, it does not. Yeah, so it's this thing. So you can even like narrow it down to something like this. And it doesn't care about like if the variables have been declared, if like if they are in scope, because it's like purely syntactic. So now you like narrow down to the whatever, like the application expression. You can even like go like, hey, I just need this, maybe this is enough. And then like you have something in application expression. So let's see. In the grammar, so we have let me just fully expand it. No, so application expression. Then we have, one of the problems is that whichever file you focus, the astronomer will start to running the tree-sitter for it. Now it's running for JavaScript, and maybe it's a good idea to like either have it in a console or in a separate window. And Vim has better tooling, but I'm not the biggest fan. So yeah, we have, for example, we have the application expression, we have the long identifier, something which hasn't been parsed, and then long identifier or operation, so which is probably part of the expression itself. Let's see. Probably it couldn't parse something like infix expression. Let's see. What is the infix op? So it's probably the infix op, which is not there. And we can add it, but we should be careful here because it's the kind of, I think it has to be in, order for the operators which have specific precedence. For example, this operator has very special precedence in a F sharp. So here we can, let's see if we can just try and fix it. So we still have our file, still have error. So now we need to rebuild. Let's see. Oops. Oops, no, I don't want to test. I want to npm build was. Hopefully it's going to rebuild it. Let's see. No, first I want to do npm run build to see that it's gonna generate. Yeah, it's generated the JSON grammar, and it should generate parser grammar, but parser grammar is very, so this file is auto-generated and it's checked in, so whoever wants to use it in their editor, they don't have to download all the sources and generate it and then compile. They can just have the parser and the scanner and just use the GCC or CLang or whatever. So just build them. So, and then I can, let's just remove the tree-sitter wasm. We can just build the wasm. Can take a bit.
Yeah, really interesting. I'm really seeing a path to contribute to tree-sitter with this, because before, I was doing a lot of changes, but some of the changes were auto-generated, and I really didn't know, what needs to be checked in or what's not.
Yeah. So now I think it's in a good place where the git ignore kind of covers everything. So whatever you made a change, did the build, whatever's changed, you can include into your pull request. So let's see if it works. Actually, I have no idea. So we reloaded it. Do we want to reload the tree? Probably yes. And now we have infix expression with operator included. So like it's a small fixes. we probably want to make sure that like they make sense, which here it is, right? Because like we have infix operator, which is, you know, at, and which is just made it work. So now if you run tests, it's going to fail with, you know, like the tree diffing here is not the greatest, honestly. But which actually maybe something which we can improve as well. You know, how do we diff, and like if we can kind of diff it in a smart way. Anyway, so if we go, let's see, what do we want to? Oh, yeah, we want to go here. We want to open the operators test, and you know, like we probably don't care about any of this anymore. And wait, so last time I was updating those baselines were by hand. Maybe it's gonna be great to have something like, let's see if we can figure this out right now. So we have test is running 3-seater test. Maybe there is something like 3-seater test. There's help, and then we can. Oh yeah, awesome. We can do the update, and it's gonna update the baselines.
That's pretty
Yes,
good.
yeah. Did it update baselines though? Let's see. Oh yeah, it did. So at least for this one, for sure, it did update it. And yeah, we see like we have the application expression, then infix expression with operator and 2 identifiers. And all this is, by the way, is queryable, as you know, as I was showing before. So you can like as like, you know, since we're kind of experimenting with this, and write query against this and extract the infix operator. So like all the infix operators, like if you just say, you know, this, you can also run the same query, and it's gonna, you know, iterate over them. Yeah, I'm again not sure how we are with time. If you know, if you want to experiment with something, or you know, go through questions, if anyone has any, be happy to.
I think we're just seeing some excitement on YouTube. Like, you know, thank you for, you know, tackling these, explaining more about 3-seater, because lately, the new editors, they are, you know, everyone is like talking about 3-seater and all of these new editors. So at least there is a path, a way for the F# community to contribute to this library that is now on Ionide. And, you know, if you want to see the tooling improve more than it is actually good now, so yeah, please do that.
Yeah, so probably one thing I can kind of maybe show a bit is how things like highlighting works, but I won't be able to demo it in the editor because I don't know how to do this in the VS Code. But on the NVim NeoVim 3-seater has a huge 3-seater queries kind of database, and which let me which is hosted here. And for example, we can take something like OCaml, for example, and see how the highlights work. So if you will, let me just copy paste it here. I'll go here and do this. Oops. Let me see that. So this is pretty much a kind of, so you, as I said before, everything in a tree-sitter is a query. And what you can do here is that we can, so all of the selectors, the type constructor or the class name or the constructor name or the value pattern, are the things which you see in grammar, like infix op or identifier or line comment, block comment. So those are, these are declared in your tree-sitter grammar. And what you can do is you can say you wanna classify type constructor as type built-in, and these things, they are, I would think that they are editor specific. So editor can then take the ask the tree-sitter and say like, hey, give me all the ranges for the type built-in, and then apply the styles, whatever you want, any style, whatever you want for them. And then you filter for like the type, like the built-in types are only those, the int, native int, format, lazy T, whatever. You then can say that everything which is module name or module type name, either of type of module. Anything class name, class type name, type constructor is of type. And you then classify, you can classify keywords. You can classify the keywords for types, keywords modifier, like we have, mutable, rec, private, public for methods, etc. Same for functions, same for conditional exceptions, etc. And you can classify operators, and then editors can use those things to pretty much, again, color or navigate or highlight stuff. And this is also something which could be helpful for the tree-sitter for F#. And arguably, people may have opinions about that. Arguably, I think that we should follow whatever is the standard for the tree-sitter grammars. Like, we like what would be the example? The let's say type, record type definition, or type definition. So like we use type definition, whereas OCaml can be probably using, let's see, type. Yeah, they just use the just keyword type. Maybe it would be worth it to rethink some of those names. And but yeah, it's up to like it's up for discussion, and like is it worth it or not. But yeah, like the highlights is declaring common queries is very helpful, especially for like if we will excuse me, if we want to say like, oh, like we want to work out of the box for Z or for Fleet or for you name it, the standard queries for highlighting, the standard queries for like locals and indentations might be a must. There is also a sorry, go.
So being more in line with what the existing OCaml entry in the database of NVim does would make our jobs easier down the line to come up with our own entry there?
Well, I would say not like OCaml, but like go and explore what other languages do and how they classify, and maybe take kind of inspiration from that, because like it will be easier to argue about like how it should look, how the tree should look like.
Okay.
Again, personally, I would say also one of the things for one of the applications for the tree-sitter, and I think it's a great application, is language injections. Language injections is that, like, for example, in a Markdown document, you have OCaml or Rust or PHP or whatever. You can just use tree-sitter to parse it, like this particular block, and use its tree-sitter and queries to like color everything properly, which is quite handy. So yeah, I hope it was not too randomized, like my explanations, and hope it's kind of clearer now. Reach out to me, I'm on Slack or Discord, or even GitHub. If you have any questions, I'll be happy to help to figure out. I'm also, I'm still learning some things as well. So like, my apologies if something is here not accurate or like not 100% accurate. Please let me know if there's anything.
Yeah, great. I don't see any more questions. If there are, you have like 5 seconds now to voice them.
I have a question.
Okay.
Yeah. So as a first contributor, like, is there a guideline? You said like maybe you should start writing tests, but like I'm thinking like what should I write tests about? Should I like run the tree sitter on the F# compiler project and see if there's any errors and like add them as a tests, or how
For
would you
sure,
approach
like
that?
F# compiler is a good code base. However, I can see you might have problem with how big some files are. And like unfortunately, or historically, we have files which are like thousands and thousands of lines. And sometimes it will be easy to narrow down the issue, like we saw with double add or the hash debug. Sometimes it could be that you have a file which starts with error and everything inside is error as well. And narrowing this down might be a bit hard, but like I would start with trying to go and go to F# code bases and like maybe take their tests, maybe take parts of their source code, just put it into the test or like put it into the debug. I'm not sure if you were joining from the beginning. I think so, but like you can do the oops. No, I don't want that. So if you go tree sitter parse hd, even without d, like you can parse and then you can go and do any file. Let's see, testfs. You will see what it gives you, right? And you can then decide to say like, oh, like there are no errors here, so I can maybe expand it a bit to see, like what if I add, like the test one is a very small one. It's like these. What if I add, module foo, and then, go and try to reparse it? It's like, okay, I have an error. So now like I can probably get rid of these and see, like probably also it helps like to kind of try to test on a working F# code. So, like you like that it's permitted to have such F# codes, like the calling thing inside of the module. And then like if it gives an error, it's like, okay, this makes sense. So like, we kind of at least know what to work with and like what's the error. And you can go and see the like reload the tree, you see the error, and the error is in line from the equal sign to the end of the file, and you can go and see all right, so it's probably when it's parsing module. So you can go here and you can find module module element. No, what was it? Named module. Yes. You can go and see it's named module. It parses the module, so you can see. You can see here that it parses the module, parses the long identifier, parses the identifier, so it's full, and then it can't do anything. So it's something which module includes, something which includes the module, because like it was successfully parsing the name, and it's either failed to repeat the module element. So it's either module element or the top level, the very top level, which is file, and then it parses the module but fails to parse something which is here, which might be expected, right? Like you don't want to, like, it's not correct. Like you cannot have, like, for example, you cannot have application in a module, or like, you cannot call the operators. So yeah, sorry, I talked too much, but TLDR is take existing code, which is, there is a high probability it's working already, which is why the existing code basis is great. You can paste it to here and play it in the astronomer, or like you can save it to file and then give the tree-sitter parse a go, see what's wrong, and like you can query for like because it's well known in the F# tree-sitter grammar, and you see in the files you can see the exact range of like what's going on, and then like you can narrow it down. You can create a test case and maybe even create an issue in the repo saying like, oh, here's the code which is perfectly valid, but it fails to parse. We need to work on it.
Yeah, it could be even, any script that you have somewhere. There I have a lot of scripts when I was learning F#, so you can just, take that and see how that works. I would definitely use it.
Yeah, sorry. Do you recommend like maybe like trying out like the test examples that we have in the F# compiler repository, and like try to see if all of them work with
You
the
mean
tree
like
system?
Example? What do you mean? Like
Like I saw some
you mean,
examples in the F# compiler, like we have tests for that compiler, right?
yeah, we can like one of I know what you mean. So certainly you can, like, for example, we have a bunch of tests, resources which we use as a just for example, that's some for units of measure, and we want to do we can go like copy this because like those like kind of they are probably fine, and unless it's testing syntax, which is probably, it will be easy to figure out from the from the path which they belong to. Yeah, you can go and to here. It's a long path. Tree-sitter F#, and can do this. Yeah, see, there is some error, and it's in oh, that's surprising. So like it failed to parse a float for whatever reason. So yeah, it's like it's kind of and you can then just get rid of this
And
for
minimize,
now.
like get the minimum
Yeah,
amount of code. Okay.
exactly.
That makes
And
sense.
then yeah, here's like singular error, and then you can go like further. You can just do this and see, hey, does it work? Oh, it doesn't work either. So yeah, what's going on here? And you can go and actually see what is the infix. So what is like what the file is getting parsed into, and then like what would this error be?
Makes sense.
And yeah, like it's either some existing declaration. Oh, I think I broke something. No, some existing declaration here missing some something. It sounds sorry, sounds very vague, but like it's either like we saw with this guy, right? So
Yeah.
where is it? So it was just missing from the infix operators. Maybe it's maybe like this regular expression is not
Correct.
right.
Yeah,
Yeah, exactly.
Okay.
And or it might be missing a the whole new missing the things like this basic hash directive, right? Like the whole new element, which which kind of we just never did it. And regarding the rules of parsing, it's in this. Yeah, this is something I did mention regarding the rules of parsing. In the Grammar.js, it's pretty much top down, so you can see like, this is the file. This is what the file can have. Like it can have repeated compiler directive, and then named module or namespace, but only one, which like repeat one means it's only one namespace per file, or many modules. And then you go into named module, and named module can have, or it should start with a module, then optional access modifier, then the name, the field meaning like you giving the field name, and then you assign it like the key value, assign the identifier, and then module element. Module element is a something of those. It's value declaration, module definition, abbreviation, imports, compiler directives again, FSI directives. This is weird actually, and expressions. And expression is the kind of funny one, because it's huge. It can be like any of those things. So it kind of feels a bit overwhelming at first, but like the more you work with it, the more you can kind of clicks, and like everything comes together, because it's just like it's a thing can contain a thing and should not contain other thing, and with like all the kind of permutations, you have scope things, you have choices, you have just sequences of things, you have the precedence, left, right, and then just kind of declare like the constant one. Then what else? Like you can declare your own expressions. So if for whatever reason you wanna treat some indent like in a special way, you can say like my indent equals, or sorry, my indent is a specific constant string, and then it will be parsed in a specific way. So yeah, it's like a lot of things you can do with it, and
Nice stuff.
but yeah, sorry, go on.
Nice stuff. I'm excited. Yeah, I think this is exciting. Parser things.
Yeah, I think you can go to the repo. Like one of the things, the tree-seeder iodide repo, there are some closed pull requests. It's not many of them. It's like 30 or so, but also some of them are just bumping of the packages. But you also can see that like there are some fixes, like yeah, like the one, I think the first one I did as we released F#7. So this one, just adding the support for the new kind of new-ish syntax for the SRTP type parameters, which is single tick instead of the hat. And you can see that the like how Grammar.js changed, and kind of gives you a good understanding like what's the what are the smaller fixes you can make, and how they how they work, and how to introduce like new variable or like new type of the things you want to parse, like introduce the trait member constraint. Yeah, so and yeah, do like reach out to me or like people from Amplifying F#, if you want any help in the contributions. Be happy to.
Yeah, thanks a lot.
All right. I don't see any questions in the chat. Any questions from people in the call? No. Okay. Yeah. Thanks, Vlad. That was a really nice session, nice introduction. I'm pretty sure we will see some more interaction, some more help now in the repo. And yeah, with that, I would wrap it up and end the live stream.